So we have this equation here and this equation right here. This one already says y. And we would usually, let me use that other color again. We would usually just plug that in. We would substitute in that 3 over 4x minus 5 into there. But I want you to check something out before we do that. So if you look here, this is this equation. And I am changing it to say y equals. So I've tried to change it. It says y equals 3/4 x plus 1. This one's y equals 3/4 x minus 5. You can already tell that these are parallel. So they won't ever intersect. Their solutions won't ever intersect. So there's no solution here, right? I'm just letting you know there is no solution here already. But I want to show you what happens if you try, okay? So 3x, that way if you end up in this situation, you'll understand what's happening. Minus 4y equals negative 4. And instead of the y, I'm going to write 3/4 x. 3/4 x minus 5. So I should get 3x. 3x minus 4 times 3/4 x minus 5. That should equal negative 4, or will equal negative 4. So let's distribute first. Oh, let me write this down. So negative times a positive is a negative. 4 times 3 is 12. Divided by 4 is 3. And a negative times a negative is a positive. 4 times 5 is 20. So before we start solving, we should put these x's together. So 3x minus 3x. We end up with 0, or no x's. So we end up with 20 equals negative 4. And remember, this is one of those situations where you're like, well, 20 is never going to be negative 4. So, I mean, this is just no solutions. So no solution. So no common solution we'll put. No common. I'll put this in pink actually. So there's no common solution. There's no solution to the system. All right, so both equations, or I think in the other one I put the, so let's put the, I don't know why I put that earlier, but the equations have no common solutions. I can't write today or any other day. So the equations have no common solutions. Another way of saying this is there is no solution to the system of equations. Correct that. There's no solution. I can do better. I'm just gonna leave it alone. Okay. There's no solution to the system of equations. But I already showed you that, right? We already knew that. But normally you won't, you may not know. You may just jump to this step. I just did this to show you that, what we were going to find out eventually anyways. All right, did you see that? It was magic. I had to make some changes. So I have these two equations. I changed this first one to show you what it is in y equals. And I went ahead, this is what it is. Y equals 1/2 x minus 3 over 2. And I did the same thing for this one to show you that I get the same answer. But most of you won't do this because you would change one of them, right? So I'm going to show you what happens. So I am actually going to take this equation since it's less familiar. So 5x equals 10y plus 15. And I will substitute in this y, 1/2 x minus 3 over 2. Okay, so I get 5x equals 10 times all that plus 15. Oops, put a 5 only. Plus 15. So we get 5x equals, positive times a positive is a positive. 10 times 1 is 10 divided by 2 is 5x. A positive times a negative is a negative. 10 times 30 is 10 times 3 is 30 divided by 2 is 15. And I still have this plus 15. If you notice, these will go away. And I end up with just 5x equals 5x. Now you could try to subtract this from both sides. Like, let me show you. You could try to subtract it, right? But then you just end up with 0 equals 0. So everything goes away because everything's equal. So like 5x is the same as 5x minus 15 plus 15. And then when we got rid of those, 5x is the same as 5x. When we got rid of those, 0 equals 0. It's going to be, there's an infinite amount of solutions. So infinite solutions. There are an infinite number of solutions. Okay. And so we can say that both equations, share the same exact solutions. The same exact solutions. And the number of solutions never ends, really. In other words, there are an infinite number of solutions. Cool. So that's it. Thank you.